So in this lesson, we are going to look at Wireshark. It's again a different tool like Process Monitor. The main difference Wireshark has, apart from the other tools we have seen, the main difference here is that Wireshark captures the actual data going on the network. It is a class of tools called network sniffers. So far, we've been seeing only the metadata of the packets or the calls our application was making, not the actual data. But in Wireshark, we'll see the actual data, the actual packets, and we will be dealing with it throughout this training. So we'll see actual data being captured, sniffed from the network card itself using Wireshark. Now again, let's not forget what we are doing. We are trying to understand our TCP/IP socket client server application. That's all we are doing. We are using different tools and we are trying to dig more and more into the application we have seen using different tools. Again, we are acting like a detective to find out more and more clues about our application. We are collecting our unknowns, collecting more information to create a theory. That's what we are trying to do. Let's not forget that. That's our ultimate goal. So let's start Wireshark to observe the program. We have already installed Wireshark in one of the previous sessions. So when you start Wireshark, it looks similar to this. This is how you see the start of Wireshark. So this is an important page which we need to pay attention to. So in this case, we have different NIC cards available in the system right now. So these are the different available NIC cards or physical network interface cards. It's a device. We will discuss about it. But these are the options at the moment which is in front of us. From this, we need to select one of the cards which we need to monitor. So in our case, it is the loopback traffic capture. That is what we are interested in. We will see most of these other things shortly. Not all of them, but some of them. But if you look here, look at the graph here. This shows the amount of data, approximate amount of data going through these cards, these devices. So for example, in loopback traffic capture, we have this many data which is going through. So what we can do here is double click on this particular adapter or device. As you can see, the IP of the device is matching the IP which we have given in the program, which is 127.0.0.1. So I'm going to double click on it and it starts the capture. As you can see, so much traffic is going through this particular interface, loopback interface. So many different programs are sending data through this interface. What we are interested is just our program. We are not interested in other traffic going through the interface. So to filter our traffic, what we need to do, just like we did in the case of Procmon or TCP view, we are going to put a filter to avoid other traffic and to stick to our particular application. So unlike Process Monitor or Process Explorer or even TCP view, one thing Wireshark is not going to tell you is the process name. Wireshark as a packet capturing tool or packet sniffing tool doesn't care about application. It doesn't matter. It works on something called physical layer. We will get into it, but for the time being, just we need to understand it doesn't care about application. Works at a much lower level of the network stack to capture these data. And at that level, the application itself is not really available. So in our case, our application is our Python. So we don't have the process ID or anything like that. So in our case, what we are going to do is we are going to apply the filter on our port was very specific. That is a filter we have used many places, including TCP view. So we are going to use the filter TCP port equal to our port number. So TCP port equal to 65432. So this is our server port. This is our listening port in the server. So let's go back to our code and see that this is our server and this is a port we are going to filter the traffic for. We have already selected this particular interface. That is the first thing we did. And now we are going to put a filter to avoid other traffic coming through this particular interface. So I'm going to apply that filter. I'm going to press enter. For some reason, this button was not working for me. Not sure, although I have the latest version of Wireshark. Also pressing enter once was not working for me. I had to press enter 2 times to apply this filter. Not quite sure, but that's how Wireshark behaved, at least this particular version, which I'm looking right now. Doesn't matter, our filter is applied, that's why all the other traffic is gone. Now, we are going to start our server. So I'm going to remove all the breakpoints and going to start our server. Server has started, all good. Now, do we have anything in our Wireshark? Nothing is there in the Wireshark. Server has started, still there is nothing in the Wireshark. Nothing is there in the wire. Nothing has been transferred. All right, now let's go with the client. So we'll put breakpoint later. For the time being, what we are going to do is we are going to have a plain run without any breakpoint. Start debugging just to see our setup is working and we are getting something in our Wireshark. Let's see Wireshark. As you can see, we do have traffic in Wireshark. Pretty much a good part of our training is going to be dissecting these lines which you are seeing in future lessons. But for the time being, let's have a quick look what's going on. So this is the number right here. Not much useful for the time being. This is a time. Again, time has different format. It's like a relative time you can think of. Time of this particular packet. This is very familiar to us. This is source, this is destination. And protocol TCP and length 56. Length of what? We don't care right now. Now info is kind of interesting. Info is saying that the port 63272 send some data to port 65432. This is a familiar number. This is our server port. So this source has sent some information to the server on this port with an information called SYN. We don't know it yet. And what is happening next? Next, the server is sending data back. 65432 is sending data to 63272. So this is a client port and this is a server port. With the information SYNAC, then again the client is sending back. There is this back and forth communication happening between client and server. SYN, SYNAC, ACK. So ACK stands for acknowledgement. So this 3 packet is a signature of something called 3-way handshake in a TCP connection. And how this has generated? This is what our connect is doing. When we do connect, this is what happens. This 3 packets is part of the connect. We'll see that. We'll use the debugger and make sure that this is what it is. But for the time being, just remember something called 3-way handshake is there and it is SYN, SYNAC, ACK. That is the takeaway from here. Now what is next? Next is push ACK. ACK, push ACK, ACK. So if you look down, you can see some more things here. When you select one of these things, the stuff in the bottom also changes if you look at. So it is keep changing as we select each and every thing. Now, when we select this push ACK part, there is something called data comes here. Only push ACK has the data inside. If you look, no one else has any data. Only push ACK has data. ACK, FINAC, none of those guys have any data. Now, what is the data? So push ACK, let's click on push ACK. So if you select the data, that gets selected here. This is looking very familiar to us. Hello world. Where is that coming from? That is coming from our client. So client is sending data to the server. So push ACK, who is sending to whom? 63272, which is the client port, sending to the server. 65432. Client is sending data to the server. What is the data? What is the content of the data? That is right here. This is the binary digit which has hello world inside it. Now server is telling, hey, I got the data. It is acknowledging. Now what? Now server is sending some data. What is the data which server is sending? It is a little bit bigger. It's a bigger number right here. This is the binary numbers which is being sent over the network. This is the ones and zeros given in hexadecimal. These are the hexadecimal numbers corresponding to this particular information. Hello world from server. That is the binary information we are sending from the server. And after getting that data, client is saying, ACK, hey server, I got the data. You're good to go. Now there is a special thing coming up from server to client. Fin ACK. Server saying, I have done my business. Thank you very much. And client is again telling, hey, I got your thank you. I'm acknowledging your fin packet. In turn, client is telling, hey, I'm also done with my business. Finally, server is acknowledging that, and there is a very graceful termination of the TCP connection. So I'm giving you a lot of information which I have not given much background about. But somewhere we have to start. Somewhere you have to see all these things, which is the whole purpose of this training. I have not even told you what Wireshark does. I have not even told you how this data has been captured. What is this data? Nothing I have told you. But I started explaining things in a little bit ahead of time. But that's okay. We have to start somewhere. That's exactly what we are doing. Now, let's spend some time on these packets. First, what we will do is we'll put a breakpoint into the client application before the connect. So the button which I'm going to press is restart, current capture, restart, so that we will get a clean slate. Continue without saving. Now I'm going to restart the server, start debugging. Server is waiting for packets. As you can see, there is nothing here. Nothing has been transferred through the wire. Now what we are going to do, we are going to start the client, but this time we are going to put a breakpoint in line number 8. I'm going to start debugging. As you can see, still there is no packet. Nothing has been transferred so far. Now what I'm going to do is I'm going to execute this one single line, connect. So that is successfully completed. As you can see, those 3 packets have come up. This time the client socket is different. It is 6325. So let's see that. 63325. So this is the same number we are seeing right there in the packet capturing tool, which is Wireshark in this case. 63325. And obviously our server port is exactly same, 65432. Now this is the almighty TCP handshake, SYN ACK, and that is created by this particular line. So in a socket application, connect is the line, connect is the action which is creating the TCP connection, just like the name, by sending 3 packets over the network, 2 by client and 1 by server. Which are the 2 packets sent by the client? SYN and the final ACK. SYN ACK is sent by the server. Just by heart this thing, we will need this a lot in future when you configure firewall, everything. So this is very, very important. This 3 packets creates the asymmetry between the server and client in a TCP connection. It comes in your security, in your firewall configuration, left, right, and center, a lot of places. Gateway configuration, NAT gateways, this gateway, that gateway, routers, switches everywhere. This has importance. Now, what is next? We are sending data. As you can see, that push ACK was not there in Wireshark. It is yet to come. So now we are going to execute line number 9 and we are going to pump hello world into the network. Just did that. Now let's see what we got. So we didn't have any breakpoint in the server. Because of that, server also has sent data back. So next time we will send breakpoint into the server as well, or put breakpoint into the server. so that we will see a little less packet server has sent us FINAC, etc. But for the time being, what matters to us is the hello world which we sent from the client. As you can see, the FINAC is from the server and the client is yet to send FINAC. Right now, the client also has sent FINAC. So one of the things we can do is put breakpoint in the server as well. Let's do that. So we'll put breakpoint right here so that we can see what are the lines which is sending what. So the breakpoint has hit. So we are going to listen. It is listening. Whenever something comes, it'll break into line number 8. Now we already have, let's clean up this. We don't have any packets yet. Now we already have breakpoint in the client. So start debugging. Again, we don't have any data yet because client has not connected. We are going to connect. As you can see, the connect is complete. The breakpoint is hit. So let's go back. The TCP handshake is done. Now the server is yet to send data. Now the server is going to listen for data from the client. Again, there is no additional packets. Now client is sending data, and as you can see, just 2 extra packets. Last time we got too many packets because we didn't have breakpoint on the server. Server is broken right here, and server will send data pretty soon, and client is about to receive. So we have only hello world in the network right now. The client has acknowledged the data from the server. Now server is going to send data. So let's do that. Server is sending data and server has ended as well. As you can see, server has gracefully terminated. So we should see the fin as well. Server has sent data, which is hello world from server. It has been sent. If you're doing this, feel free to modify all these things if you want to see some different strings here. And client has acknowledged it, and then a FINAC from the server. We will discuss about this thing in this lesson itself, fin, ACK and ACK. But otherwise, everything looks good. And now the client got the data, which is hello world from the server. And client is also going to end and going to send the FINAC ACK. So this is a very graceful way of executing 2 client-server socket application. So you have the clean exit with FINAC from both sides. We'll see the other cases as well. But ultimately what Wireshark is doing here is Wireshark is capturing the data sent between the client and server. And the place where Wireshark capture this information is in the device or the physical layer of the network. We'll talk about layers, but for the time being, it is behaving like a device which is connected to the wire, just like the name says. Just like the name says, it's a device sniffing packets from the network. That's how it behaves. So it can see the data. No other tool was able to do it. In fact, tool like Procon has the ability, it has a driver just like Wireshark, but it is not designed to do that because Wireshark is a tool to do that. So it is collecting the data. This is the main part. It is taking the data from all the layers of network. So this is a physical layer, this is a data link layer, IP layer, TCP layer. So these are the different layers of your network. So all the layers it's capturing from the physical layer itself. And this is the data which is exchanged between client and server. Now, one question is that why a connect is sending 3 packets all of a sudden? We can understand it is sending 1 packet of data. By the way, every line in this Wireshark is called packet of data or frames in more formal way. It is called frame. Each frame. Mostly I'll be using the word packet. For some reason I like the word packet. So the connect call, it's a single call, is sending 3 packets or 3 chunk of data instead of 1. For example, the send is sending only 1. This is the acknowledgement. This is only 1 packet. But in this case, 3 packets, 1 from the server, 2 from the client. Why is that? Or who is doing it? Where is the code? Who has written code to do it? So that is where the protocol driver we saw in Procmon comes into the picture. We have a whiteboard/blackboard session coming up. Till then, I'll just try to be brief about these things. So it is the operating system protocol driver, the TCP protocol driver sending these packets. Ultimately, that connect call is going to the protocol driver. That's what we have seen in process monitor. Feel free to watch that video. That driver, the TCP/IP.sys in Windows, is doing this data transfer. The actual algorithm, the logic to do this is written in that driver. Similarly, all the other packets, the ACK for this packet, ACK for this packet, FIN/ACK, all these things are done by that driver. Now, this is a graceful way of doing it. Now, let's see some exceptions, how it looks inside Wireshark. So this is the nice way of terminating a connection and things like that. Again, I'm going to restart the current capture, continue without saving. Now, this time what I'm going to do is I'm going to start the client without the server. Server is not running right now. The server is exited. There is no debugging window. So it is not being debugged. Server is not running. So what we should get? We should get an error. Now Wireshark is running. We'll see if there is something coming up in Wireshark. We ran server in the beginning before client, but then there was no packets. But this time we are doing the other way. So I'm going to press start debugging. I got a breakpoint. I'm going to go from there. So I got an exception. No connection could be made because the target machine actively refused it. It's an interesting message. Actively refused. Actively refused. What that means? That means a lot. Let's see our Wireshark to understand what this means. Actively refused means he said something. The target machine in this case, the target computer, apparently it is the same computer we are looking at. But from the protocol perspective, it's a different machine. It could be a machine sitting in halfway around the world. So we got something from that machine. What we got, we don't know. But it said something, actively refused. It said that it cannot do this connection. That's what it says in the error. Now, let's go back to Wireshark and see what it does. So the client very nicely sending the first SYN packet. This is expected. This is a random port, the client port 63420. 65432, this is server port. Server is not running. There is no Python application running for the server. Server is dead. No one is listening on this port. And the client is sending a SYN packet. It sent a packet of data over the network, over the socket. SYN has sent. But instead of getting a SYN ACK, we got a reset ACK from the server. Who is doing this? Because we don't have server. There is no application running here. Who is doing this? Reset ACK. And as you can see, the color of this thing has changed. So this is red, this is black, again red, black, red, black, red, black, red, black. So this is the thing with a TCP connection or TCP protocol, which is probably the 99% of this training is all about. We will be discussing only one protocol, which is TCP. We'll have quite a small discussion about UDP protocol, but TCP is going to be our main scapegoat for this training. In fact, I believe UDP is just a minor subset of TCP. If we can learn TCP, UDP is just a cakewalk. From the protocol perspective, not from the application perspective. UDP application writing is another challenging task. Depends on what you're doing, but TCP is going to be our focus. So this is very common in TCP. You fail in something and you keep retrying. The TCP layer is doing it. So someone has sent us information, although the server is not present, from the port 65432 from the server. How that can be possible? Because the server is not running. This is the single most important question we need to answer right now as a detective of the problem. We are seeing something very strange. No one is doing anything on port 65432. That port is completely empty, but still we are getting data from that port. A reset ACK. Who is sending that? It is the TCP driver of that particular computer. In this case, it is the same computer, but we will see all this thing in a different machine shortly. But long story short, this data right now we are seeing in the screen here, this particular bytes are coming from the kernel of that operating system, the TCP driver of that operating system, telling the client that, hey, no one is listening here on 65432. I'm going to reset this connection, get done with it. So this has a lot of security implication. This simple reset has a lot of security implications. And not a lot of servers does this kind of very friendly way of resetting the connection, because server has to do some work to get it done, and it can be misused for denial of service attacks and things like that. But for the time being, we are not going into any such details. We are trying again, and again. How many times we are trying? 1, 2, 3, 4, 5 times we are trying. Always we are getting a reset from the server. We are sending SYN packets again and again and again. We are getting quite a few warnings, port numbers reused, this, that, all those kind of things, because Wireshark is thinking that it is the same connection we are trying to establish. It's not that careful that way. So this is the look of the traffic over the wire when you are sending packets from the client without a server. And these packets are coming from the TCP stack of the server and not from the application itself. In fact, all the packets are coming from the operating system, not really from the application, because it has to add the other layer on the frames. Now, let's try a couple of different scenarios like this to avoid graceful termination. So I'm going to change the code of the server a little bit. All I'm doing is I'm adding certain line of code which Python does implicitly. I'm going to explicitly add that line here. So this is the line number 11, which I have just added, is a line which is sending that fin packet. It was already called by the Python runtime as part of cleaning up this particular object. All I'm doing is I'm just calling it here so that I have complete control on the packets which is sent by the server over the network. I'm going to save this file. Now what I'm going to do is I'm going to stop it here, and here also I'm going to close. So I will move this print down here, and I will put a print into the server as well. So I have added a print statement here and added a close and print statement move to this line on the client. Not much changes. I'm just closing the socket so that I can put breakpoint on different places. So to conclude, we are looking into Wireshark. We have seen the packets, but we didn't understand much about it. A lot of information, a lot of interesting things we are seeing in Wireshark. We don't have much explanation as of now, but we are looking at different patterns to understand more about it. So in the next lesson as well, we are going to dig more into the Wireshark, and let's continue our investigation.